In this video, we will look at the concept of graph traversal, and first we will see what graph traversal is. So graph traversal means visiting all the vertices in a graph in some systematic order. So in the case of tree, we had seen several methods to traverse a tree, which was in-order traversal, pre-order traversal, and post-order traversal. But in tree, we had a vertex called a root vertex or a root node, where we can actually start all the traversal process from. But in the case of graph, we do not have such a vertex designated as root node. So the process will be different in the case of a graph. And although there are many possible orders for visiting vertices of the graph, two methods are of particular importance. The first one is the breadth first search or BFS. The second one is depth first search or DFS. And this process will be also called as breadth first traversal and depth first traversal. Both are the same. We will be using the abbreviated terms quite often, that is BFS and DFS, for breadth first search and depth first search. In the case of BFS, first we will identify a node as the starting point for the traversal. For the sake of simplicity, I will take the node A as the starting point. So I will be taking the node A first, then I will add that into my traversal order. So A is in our traversal sequence. Then I will identify what are the adjacent nodes of A. So the adjacent nodes of A are B, C and D. So I will visit B, then C and then D. Okay. Then we will look at what are the adjacent nodes of B. So B has two adjacent nodes. One of the adjacent nodes of B is E and other one is A, because this is an undirected graph. So B has two adjacent nodes E and A. Here A is already visited, so we will not take that into consideration. So we will be visiting E, so that will add to the traversal sequence. Then we will look at the adjacent nodes of C. So C has three adjacent nodes A, F and G. So here A is again visited, so we will be visiting only F and then G. Then we will look at the adjacent nodes of D. So D has two adjacent nodes A and H, so we will be visiting only H because A is already visited. So I am adding H to the traversal sequence. Then we will look at the adjacent nodes of E. E has two adjacent nodes B and I. B is already visited, so I will be visiting only I now. Then we will look at the adjacent nodes of F. F has two adjacent nodes C and J. C is already visited, so I will be adding J to the traversal order. So this is my breadth first search traversal order. So you have seen that we will be completing the traversal in a level by level order. So first we will be visiting the nodes at the level 0, then we will be visiting the nodes at level 1, that is B, C, D. Then we will visit the nodes at level 2. The level means that those nodes are 2 edges away from the starting node. So we will be visiting E, F, G, H. Then we will visit I and J because they are at the third level. Here we are completing the traversal of nodes in a level by level manner. So that kind of traversal is called a breadth first search or breadth first traversal. Next we will see the another variant of the traversal, that is the depth first search or DFS. So here we will start the traversal from a starting node. So we will take A as the starting node. Then we will look at the adjacent nodes of A. So A has adjacent nodes B, C, D. So out of that I will be visiting the first one, that is I will visit only the node B. Now before we move to the next adjacent node of A, that is C, we will look at what are the adjacent nodes of B. So the adjacent nodes of B are E and A. So here A is already visited, so the unvisited adjacent node of B is E. So we will visit that node as the next node. So we will be visiting E. Then we will look at what are the adjacent nodes of E. So E has two adjacent nodes, so that is B and I. So I will be visiting the node I because that is unvisited. So I will add that node to the traversal sequence. So the sequence as of now is A, B, E, I. So when you look at this traversal, unlike the BFS, here we are completing a single stretch to the deepest of the graph, or we will be going to the depth as much as we can until we see no nodes further. Now we will look at the next unvisited node of A, that is C. So we will add C into the traversal sequence. Then we will look at the adjacent nodes of C. So the adjacent nodes of C are now A, F and G, but A is already visited and the unvisited nodes are F and G. So we'll take the first one and visit it. So we'll be visiting F. So F is returned to the sequence. Now we will look at the adjacent nodes of F. The adjacent nodes of F are C and J. So C is already visited, then we will be taking only J. So J is added into the sequence. Then we will visit the node G as the next node. Then A has again one more unvisited node, that is D. So we will identify that node D. Then we will add that node into the traversal sequence. Then we will look at the adjacent nodes of D. So the adjacent node of D is A and H. A is already visited, so we will be visiting H as the next node. So we will be writing H into the traversal sequence. So this is the idea by which we are traversing a graph using DFS.